My name's Goodwin. I work for Agricultural Victoria here at the Tatura Smart Farm. I'm project leader of a new project we've got up, which is called Narrow Orchard Systems. It's really a continuation of some of the work that has been done already in New Zealand, where they're looking at growing trees in rows that are spaced just at 2 metres apart and having these canopies that are very, very narrow. Now that work in New Zealand's been done on apples, and what we're going to do is investigate whether that sort of orchard design can be done in Australia. We're hoping, of course, to increase the yield in that sort of orchard design compared with the yield we get out of the trees right behind me here. The work that's been done in New Zealand, there's published some of that work where yields are getting up around 200 tonne per hectare in apples. And of course that's very attractive to the industry to get those sort of yields, and of course high levels of pack out as well, not just yield. And it's pretty important that we can test that sort of work, those sort of studies here in Australia. It's what we call a cordon system. In New Zealand they talk about a planar cordon. So planar being a narrow canopy, and basically with a cordon system you have two what are called cordons down here. So this is a cordon, this piece of structure down here, and that is obviously laid in the first year after the tree's planted, and then you have these vertical leaders coming off that cordon. In this experiment we spaced our vertical leaders at 50 centimetres apart between each one of them, and in this tree spacing, which the trees are spaced at 3 metres, we've got a total of 6 of these vertical leaders per tree, and they're spaced, as I said, they're spaced at 50 centimetres. In the new project, what we're aiming to do is space these even tighter, these vertical leaders, probably down to about 30 centimetre spacing between the leaders, so bring them in closer together, and prune these even harder than what they're pruned here. So in other words, we're just relying on fruiting sort of laterals that are these spurry type mechanisms, but we'd like to see a few replacement shoots as well, and therefore basically trying to increase the yield through sticking more fruit on each one of these vertical leaders. That was one of the attractions to doing the work, this idea that you can narrow the orchard and still get good light distribution. So these trees we're looking at here, because we've got 4.5 metres between the rows, that's allowing plenty of light to get through to the bottom parts of these trees. Squeezing the rows in, it means that adjoining row will start to shade it. But that's the real emphasis, is on making sure that this canopy is thin enough and there's enough gaps in it so that you do get light going through the canopy and onto the adjoining row, and even not just the row next door, but even rows further into the orchard. So it's all about making sure that that there's a thin canopy, there's gaps, there's holes in it, small holes, I'm not talking about large gaps, so that you're getting a really good even light distribution throughout the entire depth of the tree. We're picking up on the so-called ag tech to do our research more efficiently, so that we can actually capture more data, but also making sure that data is still precise and accurate. And so we are using technology like the mobile sensor platform, which is called Cartographer, to be able to on the go collect lots of data in terms of fruit number, fruit size, fruit colour, tree shape, the tree architecture, as well as even light distribution through the tree. And coupled with that is another technology called LiDAR, which we're going to use and create what are called digital twins. It's a common term that's used nowadays for basically digitizing something in the real world that then you can actually utilize to manipulate it on a computer. In our case, of course, what we're doing is digitizing this entire tree shape, for example, this entire tree, and then we can overlay some form of models that can actually predict what the light distribution would be in that canopy. And of course, it's not only the science and the technology we use in science, even handheld type instruments that are Bluetooth, so you're not having to take pencil and paper out in the field, but we're also cognizant of trying to utilize ag tech for the commercial grower that might put in a narrow row orchard. So in other words, as soon as you go to a 2 metre row spacing, you've got to have sufficient small equipment to be able to cope with that sort of row spacing. And therefore, we are looking at autonomous type vehicles, platforms, sprayers that can do it very efficiently, tower sprayers, for example, that are narrow tower sprayers, and even, in the long run, making it into a canopy that can be easily robotically harvested, for example. So being able to use a robot down the row that can easily identify the fruit and pick that fruit by a robotic arm or whatever mechanism it might be. So that's all. It's like a package, not just the agronomy of growing a tree as a narrow canopy and in narrow rows, but also the associated machinery, ag tech if you like, that can make that system actually work.